you, GeeCON organizers. It's been great as usual. Welcome to what evidently is the keynote. Thank you for inviting me to give this keynote. Hopefully I'll make it worth your while. This is a talk about TDD. It's got an intentionally controversial title. I will preface this by saying right ahead of time, TDD is not evil. It's also not that great, as we'll cover in a minute. So, to start with, who am I? Well, I've been at GeeCON for the last 3 years pretty consistently. This is my 5th GeeCON, I believe. I'm not tired of it yet, so hopefully see you on the next one as well. I work for WeWork, which is a company you may have heard of and probably did not realize has a tech department. We aim to change that. I'm a tech malcontent, by which I mean I tend to rail against things most people consider to be ubiquitous or dogmatic. So a couple years ago, actually I think it might have been last year at GeeCON, I gave a talk railing against dependency injection in Spring. And I'm an organizer, so I've been involved in the Israeli Java and Scala user groups. I am the former main organizer of a string of Scala conferences in Israel called Scalapinio. So if anyone wants an excuse to come to Israel and or is interested in Java or Scala, get in touch. We will begin by talking about the promise of TDD. What is TDD about? Now, obviously, you all know TDD. A lot of you probably love TDD. Actually, let's get a show of hands. Who here practices TDD? Who here, keep your hand up if you like TDD? Excellent. This talk is for you. The rest, either stick around or not. You don't need convincing. All right, let's start with a definition of TDD, straight from Wikipedia, which is the source of all knowledge in the world. Test-driven development is a software development process that relies on the repetition of a very short development cycle. Requirements are turned into very specific test cases. Then the software is improved to pass the new tests only. In a nutshell, red, green, refactor, right? You start by writing a failed test. You make the test pass. Then you make the code not suck. Which is basically this. Now, as for the benefits of TDD, so why do we even do TDD? If you ask around, do Google searches, whatever, you will find that TDD has these benefits. So fewer bugs, fewer regressions, higher quality code. If you do a little bit more digging, you might come across answers such as higher development velocity, loose coupling between components, fast feedback cycles, built-in documentation, less debugging, emergent design. It promotes single responsibility principle. The point being that if you actually go and search for it and try and figure out what the benefits of TDD are, you will find 97.1 million results. The first result, Google always gives you this pop-up of the, kind of I feel lucky embedded in the search results. It showcases this one, 20 benefits of test-driven development. 20 benefits? Beer doesn't have 20 benefits. Puppies don't have 20 benefits. I checked. If you look at the first 3 pages, the biggest number you will find is 15 benefits of puppies. TDD has more benefits than puppies. I doubt it. If you try and figure out, kind of what the expert opinion on what TDD is actually for, you will do a whole lot of searches and a whole lot of variations, and you will find no consistent theme. In fact, the only 2 experts that seem to agree on anything at all are Kent Beck and Uncle Bob, both of which talk about development with less fear. Whatever that means. I don't know. I've never been afraid of my code. Maybe you have, maybe you haven't. But that is the closest to an agreement the experts seem to come up with respect to why we actually practice TDD. Which brings us to the first takeaway of this talk. We can't even agree on why we practice TDD. You ask 10 different practitioners what TDD is for, you get 10 different answers. Now, this, unfortunately, is not very useful for us for this discussion. So let's settle on some axioms, right? If you dig a little bit deeper, you apply some biases, you have some conversations, you might arrive at a roughly acceptable definition of what the benefits of TDD are, which are reduced bug density, i.e. less bugs, fewer regressions, and better code quality. And the question is, how? Which brings us to Act 2, the practice of TDD. Robert C. Martin, aka Uncle Bob, has coined his three laws of TDD that a lot of people seem to adhere to. No production code. You don't get to write any production code at all without a failing unit test. You only write as much test as is required to fail, and then you only write as much production code as is required to pass that test. Right? That's it. The three laws of TDD. Put another way, the TDD proposes to realize its benefits with these two fundamental principles: test first and rapid iteration. I want to focus a little bit about test first, because test first is kind of the most notorious aspect of TDD. It's the most obvious thing you have to practice when you do TDD. So, the problem with test first is that if you have a problem, in order to solve that problem in a test first way, in order to write a test that proves that the problem is solved, there are certain things that have to apply to the solution space for that problem. First of all, the solution space has to be known. So for any given problem, in order to write a test for it, you need to have some idea of what good is, right? What a good solution to that problem looks like. What would good results for that problem be? For some things, it's trivial. Like if you have a calculator, then the canonical kind of example that people use when studying TDD for the first time. If you have an add function that takes in two parameters, then the result should be the addition of one parameter to the other, right? That's very obvious. Unfortunately, that is not always so obvious. There is a large chunk of problems that actually is getting larger and larger as we progress as an industry, where the definition of good isn't nearly as clear. So things like social networks, right? Your feed on Facebook. What makes a feed good? Is it something you can define ahead of time? Is it something you can write a test for? Maybe, maybe not. I don't think so. Things like search results, right? Google. What is a good Google result? Good, in that case, is the user is happy. It's not something deterministic that you can just code away. Things like recommendation engines. What is a good recommendation from Amazon on related products? Well, a good recommendation is one that makes you, the customer, buy more stuff. It's not necessarily something you can codify in a test, right? So there's a whole category of problems where TDD completely does not apply. Second, it assumes that the solution space is understood. So whether or not, even if you have an understanding of what good is, you need to have some idea of what the solution looks like. You need to have some solution in mind so you can codify a test for. The problem with that is that TDD is very, very unit-centric. It doesn't mean you don't write any other types of tests, but TDD, as it's told, as it's defined, specifically focuses on writing unit tests ahead of time. And that is a problem because for unit tests to matter, for unit tests to make any kind of sense, you need to know what the boundaries of the unit are. And a lot of the times, if you don't have a good idea of what the architecture of the solution, what the moving parts of the solution are, you don't know what those boundaries are to begin with. And once you have unit tests in place, changing those boundaries effectively means completely shuffling your units around and the boundaries between those units and the respective unit tests. So TDD is not a very good solution. It's very costly to develop systems where you are exploring what the solution should be. Next, the solution space has to be stable. So one of the common concerns for people practicing TDD is how to deal with external systems. That's why we have mocks. That's why we have kind of lightweight server type things that we can test against. Fundamentally, a stable solution space means that the answer to a particular question doesn't depend too much on external stuff, on external systems. It can be affected by external factors, which once again cuts down a whole category of software problems. It makes it hard to code stuff against, say, databases. It makes it nearly impossible to test first something like a web scraper, right? And that I can say from experience because that's what I set out to do 6 or 7 years ago, and it was a complete failure when we tried to implement the TDD style. Finally, it assumes that the solution space is finite, which means that your solution can be covered adequately by a small number of well-defined tests, which obviously is the case for a lot of things we do, but obviously is not the case for a large chunk of what the industry is about. So anything that's machine learning driven or machine vision or has a very large search space for its solution just doesn't work. Like if you if you take if you don't know this app, by the way, it's not Hot Dog. It was actually developed by the guy behind Silicon Valley. If you don't know what that is, it's a wonderful documentary about life in Silicon Valley. I didn't make that joke up either. This is not the sort of thing you can do test first, right? Your input space is practically infinite. You can't reliably test on it. You have to use statistical methods, which just are completely inadequate for test first and vice versa. So the takeaway here is that TDD is not universally applicable. There is a lot that we do that test first simply completely is inadequate for. No one seems shocked and awed. No one just fainted. Cool. Okay, so we have something that no one seems to agree on what the benefits are. Okay, we have TDD. We do not agree on the benefits, so we set up some axioms, right? We have those 3 perceived benefits. Let's assume those benefits are the things we want and the things that TDD give us. Let's assume we have a problem that can be covered test first. The next thing we need to ask ourselves is, what is how effective is TDD, right? We apply TDD to a problem. What does it give us? Does it really give us what we want? Well, circling back to our axioms, these are the things we want. We want reduced bug density, fewer regressions, better code quality. Does TDD give us what we want? Well, the hypothesis is if you only write production code to satisfy failing tests, that means you write the least amount of necessary production code for your system and that it's all tested. So I guess it means it's as close to bug-free as we can get it, right? That sounds great. Obviously, I wouldn't put it quite like that if I felt that this was a correct assessment. And here's why. To begin with, test code is still code, right? Even if you write the minimum amount of production code, what is a good ratio for a TDD project for production to test code, right? If you do a Google search for that, you're gonna have an even wider variety of answers than if you ask what is TDD for. Is 1-to-1 ratio of production to test code a good thing? Maybe 1-to-5, maybe 1-to-10, maybe 10-to-1, right? There is no agreement. Everyone only agrees that asking the question is kind of meaningless. It's not meaningless when you consider how much code you have to write. Even if you write less code, because you practice Yagni religiously and you only write code that you actually need, you still have test code that you need to maintain, you need to write, you need to debug, right? And that is a lot of code. Even if you write half as much production code and you only you have the what is considered to be probably the golden standard, which is 1-to-1 production test code ratio, you still end up with the same amount of code that you need to maintain and debug. So the ratio is unclear. The amount of code that you have to write is unclear. Now let me ask you this. Raise your hand if you practice TDD again. Now, keep your hand up if you ever had this happen to you. You have code, it has tests, the tests pass, and then later on, you find out that the tests don't actually do anything. The code is broken and the test passes because whatever. Okay, not that many hands went down actually. So although test code is still code, it can also be missing or buggy or just flat out wrong. The fact that you have tests, the fact that you have code coverage doesn't necessarily mean that your tests are doing the right thing. It doesn't mean that your tests are actually running, because if you suck at writing code, which we all do, then what makes you think your test code is going to be any better than your production code? You're going to get it wrong, inevitably. Right? So having bugs in your test code just gives you that false sense of security of having tests. It doesn't necessarily mean your code is actually bug-free. So I assert that fewer bugs is not really a consistent outcome of practicing TDD. Okay, we still have two other axioms. We're looking at fewer regressions, right? Test coverage is great. Having good test coverage gives us a safety net. But there are a lot of types of regression. Actually, I would assert more regressions have to do with things like performance regressions, security regressions, integrations that fail once you make some modification, rather than strictly changing some aspect of your code that is covered by unit tests. Now, once again, TDD does not preclude writing integration or acceptance or any other type of test, which you probably should be doing to begin with, but it focuses narrowly on unit tests as the core atom, the core unit of work for practicing developers, which means you're not going to catch a lot of regressions. And these are very, very common types of regressions. So, does it give you fewer regressions than any other methodology? That's debatable. It depends on what you compare it to. Will you get fewer regressions with code-written TDD style? Well, that depends on what you compare it to. If you compare it to what everyone likes to call cowboy coding, having no test coverage at all, sure, you're going to get fewer regressions. Are you going to get fewer regressions from code-written TDD style rather than code-written test last or some other methodology that you might choose to employ? That's totally unclear. Well then, what about quality? Well, we'll apply some science. What does the research tell us? It's a bit of a mixed bag. If you use Google Scholar or you do some searches for research dealing with TDD, you will find a lot of positive anecdotal evidence. So two very, very well-known studies. One was a study one was a study on software projects at IBM, the other at Microsoft. TDD can significantly reduce the defect density without significant productivity reduction. And the other research at Microsoft says roughly the same thing, right? So we have positive anecdotal evidence. And actually, if you read research, a lot of it has like a positive tone to it. It addresses TDD, it addresses the research, and they all claim that TDD appears to have some positive impact. But if you look at the quantitative result, not so much. TDD does not always produce highly cohesive code, at least when TDD users are inexperienced developers. Okay, well, inexperienced developers, duh, who knows? Then again, we have other studies saying things like existing evidence is not sufficient and conclusions and results can be quite contradictory. And this is a recurring theme. If you look at studies, especially the ones aggregating previous studies, trying to make sense of previous studies, you will find that not a single one of them makes a strong claim supporting the fact that TDD is a good thing. They're all very guarded. In fact, they're so guarded that you will often find citations like this. Although this and other studies show favorable results when using TDD, developers must have the correct mindset when using TDD, which requires great discipline. Okay, so there's always reservations. They're always guarded about making sweeping statements. And actually, this is to be expected. Research is a mixed bag. Well, of course it is. We can't measure quality. We don't agree as an industry on what quality is. And even if we did agree on that, we don't have enough data. All of the studies that I found, I went through probably 30 different studies, including some of the most well-known ones. The highest cited study has like 220 citations, which is nothing in academia. And even if it was, all of the studies are almost anecdotal. They cover maybe 500 developers in total over 50 projects. That is such a small sample set that you cannot make any generalization based on that. So higher quality, resulting from code-written TDD style, to my mind, is a totally spurious argument. It's not supported by the evidence because we simply cannot agree as an industry on what is high-quality code. The metrics we use to measure quality are very, very debatable. In fact, no one seems to agree on them. These are the common metrics typically used in academia. You have things like the number of methods per class. Is that an indication of quality? Maybe, maybe not. We don't know. Some classes need to have lots of methods, depending on what they do. Some classes do not. Depth of the inheritance tree. Does having a highly nested inheritance hierarchy mean your code is of lower quality? No one knows, right? This is totally anecdotal. So claiming that code-written TDD style drives higher quality code, I think it's false, right? It might be true, it might be false, actually. I wouldn't claim that it's false. I would claim that you cannot make that argument because we cannot agree on what quality in software is. Speaking of metrics, I have a whole tangent here. Ranting on code coverage. Can we agree, like raise your hand if you think that 100% coverage is a good thing? I think I scared you into complacency or something. No, 100% test coverage is a good thing. Like, I don't think there's any argument there. If you have 100% test coverage, like code coverage in your tests, you're probably testing most of your code. That's a good thing, right? We'll circle back to that in a second. So, arguably a good thing, but I think we can also all agree that the return on investment is very problematic. Driving towards 100% test coverage is dangerous. Is it worthwhile? Is it not? Obviously, the cost is extravagant, and the value is debatable. So return on investment is a problem. But even if we did agree that 100% code coverage is a good thing, and we all agree that it's too expensive, what should we be aiming for? You know, what is a good percentage of code coverage? Maybe 80? 80%, is that good good coverage? 84, 72, 15? 80%. Let's talk about 80%. What does it even mean to have 80% code coverage? Does it mean you have 80% quality? Does it mean that you have 80% as much quality as you would have if you had 100% code coverage? I don't think anyone will argue that. Does it mean you have 20% of the bugs you would have had you had 100% quality? Or rather, if you had no coverage. Sorry about that. I don't think anyone would argue that either, right? It makes no sense. Maybe you just like the number 80 because you're a fan of Pareto. I don't know. It's a meaningless number. Okay, coverage is a binary metric. You either have full coverage or you don't. Okay, there is no difference between 60, 70, or 80% because it doesn't tell you anything. It's a spurious metric. So, you know, maybe we should be aiming for 100% after all. Don't even bother because it's a trick question. Getting 100% code coverage is meaningless. Here you go, a little bit of Ruby code. I hope it's readable out there in the back, but let me read it for you. We have a calculator class. It has a function that adds two things. That function returns 4. Okay, and we have a spec that takes 2, adds 2, runs it through the calculator, and asserts that it's equal to 4. Obviously, that test is going to pass. Not only is it going to pass, you're going to get 100% code coverage. Brilliant. That doesn't mean anything at all, right? So code coverage is a bogus metric. We can't agree on what quality is. The whole thing is totally anecdotal. In other words, we can't even agree on whether TDD works. I'm not saying it doesn't. I'm saying anyone who claims it does with authority is full of crap because we don't know what quality is. So, TDD is not a silver bullet. That much I believe I have made the case for. But it is a methodology that has some very, very smart and well-respected people driving it and advocating for it. And there's a lot of anecdotal evidence that it's successful. If you ask 100 random developers, do they practice TDD and do they like TDD, you're going to get a non-negligible rate of yeses. A lot of people practice it and a lot of people like it. You will get you'll have people telling you that the practice of TDD has changed their professional lives, that they feel much better about the code. So maybe we shouldn't be rejecting it outright. To which I reply, maybe. But we need to consider the legacy of TDD. Because while TDD may or may not be a good thing, and this might be a worthwhile point to pause and say, I don't practice TDD, but I work with a lot of people who do. And I think they're perfectly competent software engineers. I don't think TDD is a bad thing. I don't think it makes you stupid or less productive or more productive. I think it's a tool. But if we're going to evaluate that tool objectively, then there's no evidence to support that it's a good thing. And there's no evidence to support that it's a bad thing. So we need to carefully consider, what does it give us? What legacy do 10 to 15 years, well, actually TDD is quite old at this point, but I mean, let's say 19 years of TDD since XP came onto the scene, right? 19 years of people practicing TDD. What legacy do we have? Unfortunately, the only legacy that we can prove about TDD is that. Dogma, from Merriam-Webster Dictionary, a point of view or tenet put forth as authoritative without adequate grounds. This is dogma. From Uncle Bob, my thesis is that it has become infeasible in light of what's happened over the last 6 years for a software developer to consider himself professional if he does not practice test-driven development. This was back in 2007, by the way. And in 2013, Uncle Bob followed this up with a blog post saying, well, I don't actually say that you can't be professional without TDD, except he kind of did. And even in that blog post, he still asserts that it's going to be that way in the future, with no supporting evidence whatsoever. Not from academia, not from industry. Everything we say about TDD, whether positive or negative, is completely anecdotal. So if TDD provides us with executable specifications and high test coverage, that is at least the things we can largely kind of agree on. You might ask, are there any alternatives? Like, okay, fine, so it's dogmatic, maybe TDD works, maybe it doesn't. What else is out there? Well, it turns out that there's quite a bit out there. So if you want to get executable specifications and you want to get high test coverage, there are alternatives. There's behavior-driven design, which, by the way, is another methodology, another technique that has never been proven or disproven to work. So it's as valid as TDD. It might be considered an extension of TDD. You might like it more or less than TDD. Try it out, who knows? There's design by contract, which has been around for a very long time. Design by contract plus property-based testing gives you executable specs with very high test coverage. That might not be a bad idea. And there's formal verification techniques, which is something that we as software engineers tend to shy away from and just lock in a corner of the room somewhere and pretend that type of technique never existed. Except if you look at some of the, not even the research, just white papers, Amazon published a white paper explaining how they use TLA+, which is a formal verification language, on several of their systems. And these are not esoteric, trivial systems. These are things like S3 and DynamoDB. These are things you use. EC2, the whole clustering infrastructure behind EC2. These are things you use every day, right? These are big, important projects. And they applied TLA Plus to some of these projects, and it turns out to have been very successful for them. They caught bugs. They wield their current code base with more confidence than before they started. And is that as anecdotal as things supporting or disproving TDD? Sure, which is exactly my point. In fact, there's another thing you might try in lieu of TDD. Test last. Huh? Well, it turns out that at least one study, and I quote, says that the achievable minimum external quality of delivered software applications increased with the percentage of time spent on testing, regardless of the testing strategy, test first or test last. So it turns out if you spend more time testing your code, irrespective of when you do it, the code is going to get better. That's not very surprising, is it? So why do we assume that writing the tests first instead of last or in the middle or 20 minutes after writing the code is intrinsically better? We don't have any evidence to support that. Furthermore, let's assume TDD does give you these things and it's preferable over the alternatives. A second obvious question you might ask is it sufficient? Well, of course it's not, because TDD doesn't cover a whole host of aspects of your code base, things like performance or interactions or security or load testing and capacity testing. Those things are just flat out ignored by TDD and the way we practice TDD. Right? TDD does not preclude testing these things. It just doesn't advocate it. So, takeaway number 4. Even at its best, TDD isn't enough. Which brings us to the conclusion. First of all, a quick recap. We cannot agree on why we practice TDD. TDD is not universally applicable. There are a lot of categories of software where TDD simply is not useful. We cannot agree whether or not it works. And even if it does, it's not enough. So, what can we take away from this? We can take away from this an age-old adage in computer and software engineering, which is that there's no silver bullet. TDD is not a silver bullet. TDD is a perfectly fine methodology if you acknowledge the fact that it's limited, if you apply it responsibly, if you're not dogmatic about it, and if you augment it with complementary techniques. The state of the industry in which if you interview to a software position and you get asked, how do you deal with testing? How do you test this or that? What is your belief system around software engineering? At the present state today, if you go to a software engineering position, to an interview, and you say that you do not practice TDD, you're not very likely to get the job. And that's screwed up, because we have no evidence that TDD is intrinsically better or worse than any of the other methodologies. So this whole talk does not rail against TDD. It rails against dogma. I have nothing against TDD. I don't like it, but then I don't like dynamic languages. I prefer static ones. It doesn't mean dynamic languages can't be used to build everything from Facebook to Wikipedia. There is no proof that TDD is superior or inferior to any of these other techniques. You should try things out. You should try various methodologies. You should figure out what works for you. You should figure out what works for your team and your company. And you should not assume that just because some smart people said so, then it's the unvarnished truth. And with that, we are done. Thank you very much. I suppose we have time for questions, if there are any. And if not, and you want to argue with me, then I'll be around for a bit. And if not, see you all next year, hopefully. Thank you.